Hallo und herzlich willkommen auf meinem Kanal. Heute zeige ich ein Altcoin, welcher meiner Meinung nach ein Potenzial hat, um im nächsten Bullenmarkt eine Verhundertfachung der Marktkapitalisierung zu erreichen. Bei mir auf dem Kanal zeige ich dir immer wieder Tipps und Tricks rund um Investments in Aktien, ETFs, Kryptos und Co. Mein Ziel ist es, in den kommenden Jahren ein kontinuierliches Einkommen aufzubauen, von welchem ich später leben kann. Wenn du auf meiner Reise zur finanziellen Freiheit dabei sein willst, lass doch bitte ein Abo da und aktivier die Glocke, dann verpasst du auch kein Video und du unterstützt mich damit sehr. Besten Dank dafür. Wie du sicher schon in der Videoüberschrift gesehen hast, handelt es sich hier um den Internet-Computer-Coin. Der Coin wurde am 10. Mai 2021 auf diversen Exchanges gelauncht und ist damals wie eine Bombe eingeschlagen. Dieser wurde noch am selben Tag auf CoinMarketCap unter den am 10 höchst kapitalisierten Coins gelistet. Auf Binance wurde sogar ein Preis von bis zu 2.800 US-Dollar für einen einzelnen Coin bezahlt. Leider war die Einführung des Coins zum schlechtestmöglichen Zeitpunkt geplant. Genau in diesem Zeitraum ist Bitcoin und damit auch alle Altcoins stark abverkauft worden. Nach rund 1,5 Jahren hat sich der Internet-Computer-Coin um die 3 bis 7 US-Dollar eingependelt, und es scheint, als hat die Bodenbildung begonnen. Wie du bei meinen monatlichen Portfolio-Updates sehen kannst, investiere ich schon seit Beginn in diesen Coin, da ich bei diesem Projekt ein riesiges Potenzial sehe. Daher rate ich dir auch mal in meiner Playliste zu stöbern, da findest du das eine oder andere hilfreiche Video. Auch würde ich mich über einen Like sowie ein Abo sehr freuen. Besten Dank schon mal dafür. Dieses Video ist keine finanzielle Beratung, ich teile mit euch lediglich meine Gedanken. Das Projekt Internet-Computer von Dfinity hat das Ziel, eine Blockchain zu schaffen, in welcher jedes System und jede Dienstleistung mit Hilfe von Smart Contracts neu aufgebaut und konzipiert werden kann und unendlich skalierbar auf einer Blockchain läuft. Ohne dass traditionelle IT erforderlich ist. Sozusagen das Monopol von Google, Apple und Microsoft zur Konkurrenz ihren respektive obsolet zu machen. Dfinity hat mehr als 270 Mitarbeiter in der Schweiz und in San Francisco. Was mich darin stärkt, dass der Internet-Computer-Coin über 100x machen kann, ist, dass diese eine sehr ambitionierte Roadmap haben. Wie auf der Roadmap ersichtlich, sind einige Projekte bereits abgeschlossen und noch mehr am Laufen, mit dem Ziel, die Internet-Computer-Blockchain schneller und benutzerfreundlicher zu machen. Die Roadmap zeigt den Status der Projekte im gesamten Internet-Computer-Ökosystem und es kommen immer weitere dazu. Ich rate euch diese in aller Ruhe mal durchzuschauen. Der vor kurzem erschienene Blogartikel von Geoffrey Miller zeigt 5 Möglichkeiten auf, wie die Bitcoin-Integration das Internet-Computer-Projekt weiter skalierbar machen könnte. Zuerst mal ist Dfinity daran, Bitcoin in die Internet-Computer-Blockchain zu integrieren. Sie versuchen das damit, dass den einzelnen Kanister jeweils ein eigener Bitcoin-Schlüssel zugewiesen wird, wodurch die Blockchain des Internetcomputer direkt in das Bitcoin-Netzwerk integriert wird. Mit anderen Worten, Smart Contracts im Internetcomputer werden in der Lage sein, ihre eigenen Bitcoin zu halten, zu senden und zu empfangen. Und das ohne Brücken, welche andere Altcoins nutzen, welche unter anderem von Hackern genutzt werden können, um die Blockchain anzugreifen. Das Beispiel von Binance von letzter Woche zeigt, dass sie von einem 100 Millionen Hack betroffen waren, der Angriff erfolgte eben genau über so eine Blockchain-Brücke. Schätzungsweise wurden in diesem Jahr bereits über 1,4 Milliarden Dollar über solche Angriffe ergaunert. Weiter gibt es auch das Problem der hohen Transaktionsgebühren. Daher setzt das Projekt Internet-Computer auf eine brückenlose Technologie für den DeFi-Sektor. Nun zu den 5 möglichen Vorteilen, was die Bitcoin-Integration dem Internetcomputer bringen kann und warum es möglich ist, dass der Coin im nächsten Bullenmarkt eine Verhundertfachung erreichen kann. Als erstens ist zu sagen, dass die Bitcoin-Integration ursprünglich auf das erste Quartal im 2021 geplant war. Aber aufgrund von technischen Herausforderungen wurde der Termin nach hinten verschoben. Nichtsdestotrotz sind die Entwickler davon überzeugt, dass die Einführung der Bitcoin-Integration viele neue Investoren anziehen wird. Bitcoin braucht die Interoperabilität mit Smart Contracts, um erfolgreich zu sein. Bitcoin verkaufte sich selbst als digitales Gold und als Schutz vor Inflation. Beides ist, wie wir wissen, aktuell noch nicht eingetreten. Um dies zu verbessern, muss Bitcoin die Herausforderungen der Transaktionsverarbeitung überwinden und die neuen Funktionen und Innovationen modernerer Blockchains integrieren. Internetcomputer wird dies bereitstellen und Bitcoin-Transaktionen mit Webgeschwindigkeit ermöglichen. Derzeit kann die Bitcoin-Blockchain nur 7 Transaktionen pro Sekunde verarbeiten. Im Gegensatz dazu kann der Internetcomputer 11.500 Transaktionen pro Sekunde verarbeiten. Das sind fast 1643 mal so viele Transaktionen. Als dritter Punkt wird aufgeführt, dass der Internetcomputer sich als Bindeglied für die Web3-Anwendung durchsetzen könnte. Hier möchte der Internetcomputer die Währung des zukünftigen dezentralen Internet werden. Und es möchte das primäre Medium werden, über das Bitcoin gehandelt wird. Man kann sich das wie ein Geldautomaten-Netzwerk vorstellen, welches sich über die ganze Welt erstreckt und es Web3-Benutzer ermöglicht, schnell und zuverlässig auf Bitcoin zuzugreifen. Weiter ist die Bitcoin-Integration ein wichtiger Test für andere Blockchain-Integrationen. Denn in einem weiteren Schritt möchte Dfinity auch die Ethereum-Integration angehen. Sie erhoffen sich dadurch, dass aufgrund der vielen Vorteile immer mehr DeFi-Anwendungen auf dem Internetcomputer angeboten werden. Als letzter Punkt meint Geoffrey Miller, dass die Bitcoin-Integration weitere Entwickler auf den Internetcomputer aufmerksam macht. Was ein gutes Verkaufsargument sein kann. Eines der größten Verkaufsargumente des Internetcomputers ist, dass Entwickler darauf Software erstellen können, die mit der bestehenden Internetinfrastruktur interagieren kann. Die Bitcoin-Integration ermöglicht die Einbeziehung von Kryptowährungstransaktionen in die Anwendungsentwicklung von Anfang bis zum Ende. Man kann sich vorstellen, dass es künftig möglich sein kann, dass Gehaltszahlungen dann nicht mehr Ende des Monats ausgeführt werden, sondern dass die Arbeitnehmer in Echtzeit entschädigt werden können. Ich finde diesen Blogbeitrag sehr interessant. Es zeigt auf, was nur die Bitcoin-Integration für enormes Potenzial mit sich bringt. Das Projekt Internet Computer arbeitet ja auch noch an diversen weiteren Projekten, wie du auf der Website von Dfinity entnehmen kannst. Das Projekt ist meiner Meinung nach eines der interessantesten, daher bin ich auch in dieses Projekt investiert und kaufe auch immer fleißig nach. Weiter kannst du mit diesen Coins mittels Staking auf Binance eine jährliche Rendite von über 25% rausholen. Das Video, wie auch du das ganz einfach machen kannst, habe ich dir oben in der Infobox sowie auch unten in der Videobeschreibung verlinkt. Bevor wir nun das originale Video von Dfinity bezüglich der Bitcoin-Integration gemeinsam anschauen, würde mich es noch interessieren, welches dein zukunftsweisendes Altcoin-Projekt ist, in welches du investierst, schreib das doch unten in die Kommentare. Wenn du das Video bis hierhin geschaut hast, hoffe ich, ich konnte dir damit einen Mehrwert bieten. Daher würde ich mich über einen Like und ein Abo sehr freuen. Damit verpasst du auch keine zukünftigen Videos. Bevor ich das Video laufen lasse, möchte ich mich bei dir bedanken und wünsche eine erfolgreiche Zeit bis zu meinem nächsten Video. Ciao, ciao.
Hello everyone, this is Andrew from the Dfinity Fundation. For the past year, we have been working on a really exciting feature coming to the internet computer called the Bitcoin integration. Once it's released, canister smart contracts running on the internet computer will be able to securely send, receive, and hold native Bitcoins without any bridges or wrapping. Today here, I have Manu with me, who's going to talk more about the Bitcoin integration. Hey Manu.
Hey Andrew.
So Manu, the community has been really excited about the upcoming Bitcoin integration feature. And to quote one of the community members, when Bitcoin integration?
Soon. Soon enough. Yeah, so actually right now our testnet, the Bitcoin testnet integration is live, so people can start building on that right now. People already are. And we will continue developing and making things rock solid, so that in the near future we can also give access to Bitcoin mainnet and call this fully stable and ready for real-world use.
Awesome. To someone who's not a cryptographer, can you explain what Bitcoin integration is and why is it so important?
Yeah, of course. So in the blockchain space, we often see that each blockchain is a bit of a walled garden to some extent. Meaning that maybe smart contracts running on one blockchain can easily communicate with smart contracts running on the same blockchain, but not easily outside of that. And this has some downsides. Like, for example, we see that there's a lot of value in Bitcoin, but because Bitcoin does not support smart contracts, we cannot use this Bitcoin in DeFi applications. And we try to address that with the Bitcoin internet computer integration, which allows canister smart contracts running on the internet computer to hold real Bitcoin on the Bitcoin blockchain and use this in smart contracts on the internet computer.
You said real Bitcoin, so how does the internet computer communicate with the Bitcoin network?
If you want to hold Bitcoin and maybe transact in Bitcoin, then you need two things. One is you need like a secret key and a public key with which you can sign and create transactions. Typically, this is like done by a hardware wallet device that holds these keys for you, and you need to know the state of the Bitcoin blockchain.
Right.
And so exactly these two properties we're going to make available to canister smart contracts on the internet computer. So the internet computer consists of subnets, and each subnet is powered by many machines across the world, which is where the security and the decentralization comes from. These machines that power the subnet now also talk to Bitcoin nodes across the world to learn about the latest Bitcoin blocks. And the subnet then agrees on which Bitcoin blocks are new and should be taken into the subnet, and the whole state of Bitcoin is now captured in the state of the subnet, which is now accessible to canisters.
And how does a canister hold the private key without it being read publicly?
Yeah, that's quite the challenge indeed. So as you're already hinting at, like, we cannot just keep this secret key in your smart contract memory, because typically you assume that this is not always confidential. What we do is we give canisters an interface to request signatures. And behind the scenes, the replicas that power the subnet do some multi-party cryptographic protocol, some threshold cryptography to construct a signature when a canister requests one. And the goal of this, of course, is that the secret key does not actually exist in one place, but only pieces of it are shared between the replicas. And when they collaborate, they can reconstruct a signature whenever the canister requests. And this way, a canister can really request signatures without the secret key being somewhere in an insecure state.
What does it mean to request a signature?
It means that the canister is the only canister that's authorized to say, I want to request a signature with this key. And then all the replicas respond to that by participating in the multi-party protocol, this threshold ECDSA protocol, to then give the canister the signature back.
Right, and with this, multiple canisters or multiple nodes can sign one message.
Yes, with this, a canister can request signatures under their own key in a way that the secret key is still secure because it does not exist in one place, but it is distributed between all the replicas that power the subnet.
And that's why it's called threshold? So you need a certain number of these replicas to agree? Or
Exactly.
Okay.
Yeah.
The threshold ECDSA is, as I see, the main building block of Bitcoin integration. What else can developers use it for?
Yeah, actually, I think it's a very flexible building block. So ECDSA is this very, very standard digital signature scheme. So this is not just used in Bitcoin, but in many other blockchains as well, and also outside of the blockchain space, just in many digital systems, ECDSA is a very common signature scheme. And so now a canister has a way to create such very standard signature schemes and authenticate to anything on the outside world. And so this is what we use to integrate with Bitcoin, but you could also imagine, for example, using this to sign Ethereum transactions or even make digital certificates for domain names. There's many options that you can think of building on this feature.
But if I understand it correctly, this means that when two canisters send real Bitcoins between each other, then that is mined by the Bitcoin blockchain network, right?
Correct.
So what are the costs that are associated with these transactions?
Yeah, because they are on the real Bitcoin blockchain, they're as expensive as other Bitcoin transactions, and also like not as fast as maybe other blockchains. So that fee is the same as for other Bitcoin transactions. Now, for running this on the internet computer, you of course also need to pay some cycles, but this would be maybe the equivalent of some USD cents.
So in principle, we can create Ethereum transactions.
Correct. Yes, that would be one other application. Yeah.
So we already have things like wrapped Bitcoin on Ethereum. What is the difference in the internet computer?
Yeah, so we see things like, as you mentioned, like wrapped Bitcoin in other blockchain systems that also tries to use existing Bitcoins for smart contracts. On a technical level, it's quite a different solution. In this solution, the idea is that there is some, I guess, central party in the system that says, you can give me Bitcoins on this address, and in return, I'll give you the wrapped Bitcoin token on the Ethereum blockchain back.
Right.
And maybe vice versa. If you want to go back, then you give me your wrapped Bitcoin, and I'll give you the real Bitcoins back. But this, of course, is a bit of a centralized component in this whole decentralized world. So here, this party is responsible for doing the bridging and needs to do that correctly, and is quite a security risk as we've seen in the past.
And one important question, how can we avoid to see these headlines of hundreds of millions of dollars hacked and stolen from the internet computer using the Bitcoin integration?
Yeah, that's a good question. Yeah, I think there's multiple parts of this question. So we are now building these low-level APIs that allow canisters to hold real Bitcoin. And so there we are doing our very best to make this rock solid, right? We're being very careful in how we implement this. We've done internal and external security audits, and now we're also taking our time to further make sure it's rock solid, such that that part is really secure and trustworthy. But now the next step is that canister developers build on these APIs, build on these new functionalities to make cool things with that. And there, of course, we have to hope that the canister developer also does a good job and builds it securely. So here I would recommend that people do some research before they maybe invest in some application that builds on this. It sounds reasonable that they would also do some security audits of their code.
I guess we have to make it somehow easy for developers to use the Bitcoin integration and not to have these security risks.
Yeah. And so here also the CKBTC comes into play. CKBTC stands for Chain Key Bitcoin, which is a token that we plan to create. The idea is to do something functionally similar to wrapped Bitcoin. So this would be like an internet computer native token, meaning it can transact very quickly. We can use the efficiency of the internet computer. But now the crucial difference between other forms of wrapped Bitcoin is that here a canister smart contract would be doing the wrapping. So this canister would build on this direct integration with Bitcoin, and so now a user can send real Bitcoin to that canister smart contract, and now the smart contract, the canister, will issue me these CKBTCs in return, and those I can now use very quickly and efficiently on the internet computer. And if I ever want my real Bitcoins back, I can send them to that canister and ask them to get real Bitcoins back.
And in the meantime, it is the canister that is holding the private key, or it's the replicas that are...
It is, behind the scenes, it's the replicas that hold these shares of the secret key. So it builds on this threshold ECDSA feature to actually control those Bitcoins.
Is it easier to transfer CKBTC than using the native Bitcoin network?
Yeah, I would expect that working with some IC native token will be much easier for canister developers than working with the direct Bitcoin integration.
Yes, because for the Bitcoin integration, when you send native Bitcoins, the ledger that we use is not on the internet computer, but it's on the Bitcoin network.
Correct.
With the CKBTC, the ledger is also on the internet computer?
Exactly.
Did I get it right? Okay.
Yeah. To do a real Bitcoin transaction from a canister, you would have to initiate this transaction and then wait a long time because these transactions are not giving you quick finality. Yeah. So you would have to remember this and later look back at the new Bitcoin state and then see that your transaction went through, and then you can continue. And of course, if this all takes place on the internet computer, it's a bit faster and then easier for the developer.
Okay. If I understand it correctly, what we have currently is on the IC mainnet, you're able to create transactions on the Bitcoin testnet. And once, as I start developing it, what do I have to change if I want to then switch to the Bitcoin mainnet launch or release?
Yeah, so hopefully nothing. The interface should be exactly the same. You just say Bitcoin mainnet instead of Bitcoin testnet, essentially. So we just launched this now as an experimental feature, and we limited access to Bitcoin testnets. I guess also to give more time to make sure everything works as expected. And then as soon as we feel there's enough confidence to access Bitcoin mainnet, we'll turn on these APIs, and then it should be no effort for existing dApps to switch to Bitcoin mainnet.
And what is the difference between the two on your part? What do you have to still do? What are the next steps that are still in development for the mainnet?
On the threshold ECDSA part, we mainly want to run it on a larger subnet, such that the key is shared by many more replicas, thereby increasing the security. And here, I guess this is mainly a performance challenge to make this as fast as we can. So that's the main thing we're focusing on. Actually, for the Bitcoin integration, it's somewhat similar. There, I guess we want to be resistant to very long Bitcoin forks, which means we need to hold a larger piece of Bitcoin blockchain state, which also has some performance complications. So those are the type of things we're still working on.
So once we have the mainnet release, is the testnet going to still be available?
Yes, yeah, we plan to keep this Bitcoin testnet available just like it is today. We think that's going to be a very useful feature for developers to test their code
it's cheaper
with low stakes. Yeah, exactly.
And if you screw up, then it's still... Yeah.
Exactly. So, so we plan to keep this available, and then you can test there, and at some point, flip the switch to target mainnet.
Right. And what languages can I use?
Well, Rust and Motoko, definitely. So we have example code in both languages. If I understand correctly, I think ASL, so TypeScript, is supposed to support this as well. So hopefully that comes as well.
Awesome. So how do you see the Bitcoin integration feature changing the DeFi landscape on the IC? And also, do you have any use cases that you would like to see?
Well, I would imagine there's quite some value coming in, right? I would expect that the decentralized exchanges on the internet computer might be among the first to adopt this technology. I think one very cool thing that I'm looking forward to is that you'd be able to get ICP without going through a centralized exchange by taking your Bitcoin and moving it into the internet computer and there trading it for ICPs, for example. Right. I think that's an exciting use case, and I'm sure people are going to come up with much more creative ideas.
So you've worked on this feature for the past year. How does it feel like to finally give it to the public and release it to the world?
It's very exciting. When we had the first Bitcoin testnet transaction go through from a canister, that was a very nice milestone. So yeah, I'm very much looking forward to see this in the hands of developers and yeah, look forward to what kind of cool stuff they can build with this.
Yeah, we probably have a lot of applications that we can't even imagine that would be possible with using Bitcoin on the IC.
For sure, yeah. I think there's a lot of, first of all, DeFi applications that I guess are the most obvious things to build, but who knows what people come up with.
And if I want to start hacking, where should I look?
We have documentation on our website that describes how you use this and example code, and so I think that's a great starting point to start building on these features.
Cool. Before we go, thank you, Manu, and all the teams involved that made Bitcoin integration possible. This is a really exciting time to be building on the internet computer. And if you're a developer, please look at our documentation. All the links are in the description below. We can't wait to see what you will build using Bitcoin integration. Thank you for watching.